Alright, hi, this is my Mech 368 project, and here's my student ID. I'm Mohammed Sufyan Ferrani, 401322826. Okay, so the project is essentially an LED flasher circuit, which switches on whenever light is not detected, meaning that whenever you cover the light sensor or the photocell, or whenever it's in darkness, this circuit will activate. Also, the blinking of the flashing LED can be varied with a potentiometer over here. With varying resistance, you can have different frequencies. The higher the resistance, the lower the frequency. And that's the main function of the circuit, but the secondary function is a buzzer because there are two parts of the circuits essentially. The first module is the switch and the second is the oscillator. To ensure that the switch works constantly, I put the buzzer, which is connected to the emitter of the transistor that acts as a switch, in order to detect whether current flows to the next module or not. So here it goes. Okay, so if we bring the light closer, we see that there is a detection of light, and there is nothing that's happening. Now as you go further, turn off the light and cover the photocell. Press on the buzzer because of the connections. You can see that the buzzer is on and the LED is flashing. Now if we want to increase the frequency, here's a potentiometer. We can switch to lower resistances. And this increases the frequency. Sorry about the buzzer, it's the connections to the breadboard are not good. So yeah, here you can see. And if you you increase the resistance, clearly the frequency is way lower. And there's still current through the buzzer. Alright, so now I'm going to take measurements of three principal values. First, there's the voltage input in the oscillator, in the op amp, coming out from the emitter of the transistor. That when the light is not detected and when the light is detected. So two values for the voltage. And lastly, the frequency of the oscillator, of the LED flash when it oscillates. I'm going to do that by counting how many flashes in 50 seconds and divide that to get the hertz. Before I start, there are a couple reasons why we could see some discrepancies in the values. First of all, the transistor itself, the specifications are very unclear. The offset voltage varies between 0.65 volts and 0.85 volts, meaning that any values between these should have been used for the estimations in the analysis and the report. Also, there are internal resistances in the multimeter and the battery, which were not taken into account. There is also, generally speaking, resistances have tolerances, and this could vary the output voltages. And also the connections on the breadboard are not so good, which explains why the buzzer wasn't beeping really quick. Okay, so now I'm going to insert pictures of each of the measurements.